Hello and welcome back. As you can see over there we've got the preamp, which is to all intents and purposes finished. I've got it connected to a Yorkville professional studio reference amplifier. It's I think only a sort of cheap thing, but it does the job. It's quite a good amplifier actually. So as you can see we've got a couple of 6 CJ7s in there. Volume control works. The only thing I'm not keen on just at present is the brightness of this LED, which needs toning down a bit like that one. I think it's a little bit bright. So we've got that to sort out and a few other little bits and bobs, but to all intents and purposes it's finished. Let's go and bung it on the bench and have a look at it in more detail. I've just turned it off and I'm bringing it in basically to have a look at how hot everything is, because we've got regulators and the chassis in the power supply is acting as a heat sink. So first, that's okay. I haven't put all the screws in. Let's have a quick look at this first. Those caps are a bit warm. Right, that's not too bad. I'll just put that aside a second. Next, to have a look at the power supply. This is warm. This is the side with the regulators, diodes on and everything. That's warm to the touch, but okay. And the toroid is warm, but toroids run a bit warmer than EI transformers. But yeah, that's acceptable. The other thing is that drop-in resistor. It's fine. Yep, everything is fine. There are a few things that need finishing on here. We've got to relabel these fuses, and then the other thing I wanted to change, or I thought about doing differently, is how we stand that. If you saw previous in the living room there, we had it like that. If you look, the label of the supply and everything is on this plane. Originally this would have had that on the back, sorry, something like that, so it can be mounted on a wall. But the other thing I was thinking of doing was putting the feet on the bottom here instead of here. The other thing I noticed when using it was that this cable isn't long enough. It's about a metre long, a yard long. It can be, yeah, it can be a little bit longer really, because it wants to be longer, so that will need replacing. And also the gauge of it is a little bit too thick really, although yeah, I'll have to have a think about that and do some calculations. But if we could have it standing like that, I think that would be better. Also gives the potential buyer the option to mount it on the wall with this plate. A few last words about heat. Because they're getting a little bit warmer than I would like, I think a few air holes in the chassis would be beneficial. They wouldn't hurt at all around here. Mind you, I don't know. You see, some heat is transferred from the valves themselves. I mean, what? There's nearly an amp. There's nearly about 6 watts. So that's what. Say, let's call that 10 watts between them of heat. Yeah, a few holes would be beneficial. And I've had to make a few changes to the circuit. As you can no, I didn't show you these last time. Originally I was going to use these capacitors as the blocking capacitors. This is our output here from a cathode follower, and that's just, and there's about 100 volts there. That just stops any DC, you know, being on the output and the input to the power amplifier. These were leaky, so they're no good. I was going to use these Weimar or whatever you call them, 4.700 volts capacitors. They probably would have been alright, but it's really, yeah, it's a bit dodgy running them over the 100 volt specification, so I discounted those. In the end I had some of these in my drawer. They are Vishay 470 nanofarads, 440 volt X-type capacitors, MKP, I can't remember what that is, some sort of polyfilm. I used these. There is not much difference in frequency in the 3dB frequency cutoff. We're talking with both, with the 4 microfarad and these 470N. The response is under a hertz anyway, so there's not much difference. The difference is, the big difference that really counted was the DC on the output. The DC on the output of these is very low. On these it is about 7 volts. I measured on one, and 15 volts at one point. We'll measure those in a minute. I'll show you how to go about checking the leakage. The other changes I made was to put some 1 meg resistors, grid leak resistors, from the input grid to ground, because I was getting hum and the output was floating about. I didn't like that part of the design originally. Yes, on the original design. If you look, find me pokey thing. If you look, originally the idea being was to have a 310 grid stopper there, no grid leak exactly, you know, no grid leak, but this pot potentially holds this grid at ground. I never liked this sort of setup. So what I've done, I've put a 1 meg straight on the grid. It's important that grid stoppers and grid leak resistors go as close to the pin as possible. This stops any instability, any potential instability, which isn't a problem on these 6CG7s because they're not really an RF valve. And then the other thing, I did away with this 310 grid stopper. Didn't need it, I don't think, and I replaced that with a 10 nanofarad capacitor in case somebody connects it up to a input that has DC on it. That blocks any DC. This is a lot better. This is. The hum was a hell of a lot better with those on there. So to put some voltages on there, we've got about 230 volts here when it comes off the power supply through the umbilical. 4K7 dropper here, that acts as an RC filter to drop any ripple further. We have got 112 volts on the anode voltage VA. We've got 2.2 volts on the cathodes. On the cathode here where are we? We've got 115 volts, which mirrors that more or less perfectly. So, I mean, this is what I was saying before about the cathode follower being a flipped version of your normal sort of valve stage. And so, yeah, the valves I used eventually were some Yugoslavian 6CG7s. Both are more or less identical. So I think that covers the circuit. One last thing to talk about with this. As you can see, I've fitted a fuse, a HT fuse. It's superfluous really. I tested this to when I came to choose the final fuse value. I had the amplifier powered up without any valves in, and then I've got a jumper wire there going onto the HT that comes in, which is at about 230 volts, and got a screwdriver, got a jumper connected to a screwdriver, and I started shorting that out to try and get the fuse to blow. Sparks were coming off this. I don't want to do it again, it's pointless, take my word for it. Can you guess why the fuse wasn't blowing? The reason the fuse wasn't blowing was because of these drop-in resistors here. Any short we get from here to ground is just going to be absorbed by these resistors, so the voltage is just dropped across these resistors and doesn't blow the fuse. I did fit a 20 milliamp fuse at one point, and that blew when powering it up. So I've got something like I can't remember, but I got something like 100 milliamp fuse just in case. There should be no chance of any HT shorting to this chassis. I tried the old screwdriver connected to there, shorting it like that. Nothing happened. So this paint acts as a barrier. There's no way it can short anyway really. We've got a big bit of heat shrink here, this is floating up here, and that's not going to suddenly somehow touch that. The only two connections really are here and here. They're well soldered in, even if they came loose they're propped up by these wires here, here and here. Shouldn't be a problem at all. I think that covers everything about this. I've got all the wires in, connected all the wires, all the grounds that were previously floating, connected a tape out wire which basically is just connected to the output of this, switch. It's probably really redundant as not many people tape anymore, but potentially it could be used by somebody, so I think that's all there is to talk about that. The only thing to finish off on here is to just put some labelling about the value of the fuse. That covers the preamp. I think there's nothing more to say there. This power supply is all just about finished. There is one final piece of circuitry that needs fitting on here, and that's a crowbar circuit on the heater power supply bit thingy, power supply circuit. This is a rough sort of schematic of what we got. A crowbar, for those that don't know, just acts potentially like this wire that I've got here. It puts a direct short across the output of this regulating circuit here, and it should blow this fuse. Why do we need it? Because we've got a regulated circuit here. We've got 13.5 volts here on this big cap. If any of these two, well they are, if either this transistor or this LM317 fails and we get 13 volts here at this point, which then goes onto our heaters, it's not going to do the Volta power good. The LM317 has short circuit protection, I think, anyway, but to be 100% safe and sure, we need to add a crowbar circuit. I've just knocked the circuit up here on this little bit of thin copper clad board. Just use the Dremel like I usually do to just make a few traces. It's very simple. We've got a Zener diode there, a 6V8 or 6.8 volt Zener. That's connected to the output of our TIP 3055. So we've got about 6.4 volts here. That is lowered by the time it gets to the heaters themselves because there's a voltage drop through the umbilical cable. The current through the Zener is limited by this 1K2 resistor to about 5 milliamps, and then we've got a 100 ohm resistor from that point there to the gate of the thyristor SCR. We've got a 100 nanofarad cap across that gate. That's to stop any transient sort of spikes or potential false triggering of the SCR. So what happens is, how this works is, if we get a higher voltage than about 7.1 volts here, this Zener will conduct, putting a voltage on the gate of this thyristor, will trigger the thyristor, that will turn on, creating a short and our crowbar like action, and then should blow the fuse. I'm powering the crowbar circuit up from this handy dandy Farnell L35 power supply, and we've got the current limit just a little bit past like its lowest setting. We've got it set to, I don't know, not many volts at the moment. We've got it set to just a few volts at the moment. So currently our voltage across the crowbar is 700 millivolts. Increase that about 5.7 volts. So as you can see, at 6.3 volts we're fine. There we go. So at about 7.1 volts the crowbar triggered and effectively shorted out our output. In the case of our bench power supply, the current limiting circuit came on, but if this was mounted in our preamp power supply across the heater supply, then that should blow the 1.6 amp fuse from the mains transformer. The AC winding that goes through a fuse into all a diode, into a diodes, you know, a rectifier, LM317, TIP 3055, and that should protect those quite happily. So I think that covers all the sort of technical aspects of it. One thing I haven't covered so far. The one thing I haven't covered so far, I did put a potential divider across here. Potential divider is just a couple of resistors to elevate our heaters to at about 70 volts. Because our cathode here is sitting at about 100 volts, I mean that is still well within our 200 voltage cathode, heater cathode limit of 200 volts. However, it won't hurt it from a hum point of view, lifting the heater supply above ground, but it also puts that, well, 70 volts, if we're talking 110 volts there, then yeah, it just makes everything a little bit more comfortable for the valve. So let's put it all back together, bang it on the oscilloscope and have a look at the output and all the rest of it. Right, let's turn it on. So that's something that I think is okay, but not too keen about. When you first turn it on for the relay that cuts the HT to the preamp, that comes on a bit sudden. Sometimes it sort of bounces a bit. I don't know if I need to put maybe a couple of capacitors across the contact or something, or I'm not quite sure, maybe a diode or something to be looked at anyway. Another sort of minor thing that, you know, that you sort of tend to have to do when you build your own amplifiers, Velp preamplifiers, or anything for that matter. Okie dokie. Right, as you saw, the volume control did its thing. It's all working okay. We've got a sine wave, so I'm going to take you off the tripod and let's go to wobble cam. We have 500 millivolts going in. As you can see, a nice stable sine wave out. So I pop you down and have a look at the HP Doodah audio analyzer. Just turn the volume up a little bit more. So we've got 1.3 volts there. The volume control isn't at halfway yet. So have a quick look at the distortion. And as you can see, that is at 0.06. And let's crank it all the way up to full output. You just adjust the scope. That's at full output. Still got a nice clean sine wave. And that's 4.86 volts. And we've got 0.2% tickle harmonic distortion. Let me just try 1 volt input. Obviously that's going to be bigger. Still not clipping though. And the distortion is actually dropped to 0.4, and we have an output of 9.7 volts, so nearly 10 volts RMS. Turn that down. Let's turn that right down and take the input off, and then let's have a look at the noise. So where are we? Right the way down. You can see I can't see anything on the scope. That's times 10 on the scope. And let's have a look at what it says on there. Let's have a look at what the audio analyzer says. Having trouble getting onto a reading, but we're talking less than a millivolt. So let's put our, oh, and that's with the volume control zeroed. Volume control at full, 0.5 millivolts. So that's really good, I'm really happy with that. One final test to do. Let me just get this set up. So far, as an output load, I've got an RCA connector with a 100 kilo ohm, with a 100k resistor just across that. So let's take that off, and what I've got here what I've just plugged in is this big long lead. So the reason you need a pardon me, the reason we need a cathode follower on your preamp is to drive any capacitance that we get from a cable. It's very unlikely that anybody's going to connect. This is about 3 meters long cable up. So let's have a look at the output there. Let me just hold that. Where were we? We've got 9.7. So basically, if that capacitance is affecting, if the cable capacitance is affecting the output in any way, we should see a drop of voltage. And we haven't really, have we? Maybe, what was that, 2? No, there's no discernible drop in voltage. Let's see, if we put the scope on, let's see what, one moment. So that's our output on more than 3 meters of cable. I think that bit of bouncing about is just a connection on the cable there. Damn pigeons. Freak me out. You're messing about with high voltage sometimes and the buggers jump on the roof. Go away. So as you can see, everything's cushy. It all works well and I'm really pleased with the outcome. So I'll get those finishing touches sorted out, listen to it a bit more, and away we go. It is really nice having a automated remote volume control. Save getting up off your arse like to, you know, when your music's just not quite right. Oh, the one thing I did want to mention was on the circuit board of the remote control volume pot, there is provision to trigger a, one moment, there is provision to trigger a relay, a 5-volt relay. Unfortunately, all the relays I've got are higher than 5 volts. I did think using that on and off to enable a mute, basically just a relay, just to cut the input. So yeah, that's another thing I could do, or maybe that's just gilding the lily. And what else did I want to say? Oh right, the only other thing I wanted to say, yeah, it's got quite a few protection circuits. The relay to cut HT to the preamp when there's no power on, so there's no chance of a shock. The crowbar, the fuse there going to the preamp, but I wanted to make sure that everything was right. I wanted to make sure that everything was right. The problem you have with an umbilical, with a separate power supply and an amplifier or a preamplifier, is that this sort of thing does present problems. This is mains reference, the chassis is. This isn't as such, but then again it hasn't got mains going to it. It is mains reference in that the power supply is grounded to the chassis, same as the mains, but it has no dedicated mains earth, as it were. I can't see that it needs one, to be honest, but that's another side of building your own amplifiers. It's alright for your own use, but is that strictly within the law? Yeah, it's an iffy one, that. So anyway, think on. Right, that's it, end of. We got there in the end. Sorry it's taken so long to get to the end. Had the flu, life gets in the way, motorbike to fix, all the things, you know, come up in life, you know what it's like. Hopefully, like in the future, near future, we'll be building another ramp, and there's a few other little bits and bobs that I've got to cover as well. Thank you all very much for watching. Take care of yourselves. Ta-da for now.